Hi everyone, my name is Pierre-Hugues. Welcome to the JVM Tridom Analysis Generation Techniques Part 2. So what is the agenda for today? So essentially this is a continuing session from the Part 1. So today we're going to learn how to generate thread using Apache Tomcat 9, right? Which is one of the most or the top most popular Java container on the servlet container side. And we're going to learn also as the second subject today how to generate consecutive thread dump snapshots in order to break down the response time of slow requests. So I'll start to show this technique as well as the part 2 of the session today, which is very useful for production support role. Again, on the technology stack, we have similar setup as the last video, essentially Java Hotspot 1.8, 64-bit of course, Apache Tomcat 9, which is the M4 build, and the Ubuntu 15.04 still in our lab environment. The third generation tools are going to use today are again the OS native command, kill-3, the JDK JStack utility, and Java Visual VM. So those are the tools that we're going to use also to explain that technique of generating consecutive snapshots in order to identify the root cause of slowness. Here's our lab setup. So as you can see, we did install the Apache Tomcat 9. So what you see here is the manager console, right, of Tomcat. So I'm not going to spend a course on Tomcat today, but essentially that's the default console that we use for Tomcat. And what we did was created a very simple program. Essentially it's a JSP file from the example web app of Tomcat 9. And the only thing that we did was to initiate a bit of a sleeping of the thread, right? To simulate a request or a JSP execution time taking 60 seconds. This very simple program will be very useful to demonstrate the thread dump generation techniques and the consecutive approach as well. Okay, so this is the program. As you can see, essentially just requesting the thread to sleep for 20 seconds and we're doing that 3 times in a row just to generate a different line number, which will be easier to track from a thread stack trace from a thread dump. So back in the console, right? So of course when you're running Tomcat on Linux, in order to get a thread dump you need the PID of the process, right? So here as you can see this is a default installation of the Tomcat 9. Tomcat it was already started just to save us some time. So first thing you want to do is extract the PID of the Tomcat process, 3361 in this case. Okay, so that's you're getting from the actual console of Linux. Now I also have Java Visual VM open. So as you can see, Java Visual VM was able to detect our Tomcat process with PID 3361, which is the same one here, of course, from the console. So now I'm going to demonstrate a technique to generate a thread dump. As we saw at the beginning, there are 3 techniques that you can use. The first one, which is the native one, is to use kill-3. So where's the thread dump printed, right, for the kill-3? Well, you need to go under the default install of Tomcat. As you will see, there's the catalina.out log file. The thread dump always gets printed out in the standard output file, as we saw in the earlier session with Oracle WebLogic. Now I'm going to generate a thread dump kill-3 using the PID of Tomcat. That's it. You won't see anything in the screen. The thread dump will get printed out, as you can see, in the log file. So if you do a quick more on the Catalina log file, there you go. You can see the thread dump was generated just now, and of course it contains the detail of all the threads at that time. Of course, there's no requests being executed right now, so there won't be any data to analyze for us. Okay, so that's just to show the technique. So kill-3 for Tomcat, typically we will end up in the catalina.out file, which is standard output. Of course, it depends on the configuration of Tomcat. Might have a couple of options, but that's the default location where you will see the actual thread dump file. The second technique is to use a JStack, as we saw earlier. That one is also quite good. Instead of again a native, it will just print the thread dump in the screen, JStack with the PID, and you get this time a thread dump from the actual console directly. That one is also very useful when you do profiling type of analysis using thread dump. And finally, Java Visual VM itself. So here, as you can see, the process is attached. Java VM is monitoring the thread. So from Java Visual VM directly, you can monitor the Tomcat help, and of course, you can generate a thread dump here, which similar to what we saw in the Catalina and JStack, you will get the native information about all the threads. So now back to the program. So as I said, we created a simple program to show you the thread in action. So what I'm going to do now is execute the actual JSP. So I'm going to generate a few requests. You see, I'm executing that JSP that I called slow thread JSP, which will sleep for 60 seconds. And now we're going to start. Let's start with Java Visual VM first. So if you look on the threads monitoring sections, you will see some of the threads in Tomcat are now sleeping. Now if you get a thread dump here, we will locate the threads from Tomcat. So Tomcat typically will be using that thread naming convention, HTTP, non-blocking IO, right? And then the port, the listen port of the Tomcat process, and then the thread execution. And if you look at the stack trace, this is precisely our GSP, right? Since we initiated a GSP file, you can see that that thread, line 116, which generated the servlet from the GSP, is actually sleeping. And if we scroll down, since we did a few requests, we can see there's another thread 36, doing the same, but this time at line 117, right? That's what we want to generate because we have 3 calls of the thread.sleep, so you will see a different line number depending where the thread is sleeping. So as you can see from JavaRum, it's fairly easy to isolate the actual thread itself. Now let's redo the same, generate a few more requests. This time we're going back to the JStack. So I'm going to generate JStack. And then of course you can locate the actual thread. And you can see the data. The thread is actually sleeping at line 116. If you get another one, now you will see the thread is sleeping as line 117. You see that typically the goal of JStack can generate multiple snapshots, and the same can be achieved also. Let's say we get a few more requests. We'll do a kill -3 again, process ID, right? Then we'll look again at the Catalina.out. Then can search for actual sleep, and then you will see the actual thread 38 sleeping at line 118. There's another one 37, right? And it's fairly easy to search, especially if the log file is not too big. You can look for your application or the pattern of slowness, so it's fairly straightforward. But of course JStack is very convenient since it's printing the data directly from the console, so it's very useful. So those are the techniques, right, for Tomcat. It's fairly straightforward. Tomcat is very lightweight, so fairly easy to monitor. Now I'm going to show you next what I meant in the beginning by consecutive technique. So if we go back at the program, you can see, right, the thread is sleeping every 20 seconds at this line, then after that will sleep again and sleep again, so 3 times. This will generate a different line number. So when you have a problem, let's say in production, let's say you have a high response time of, let's say, 15-20 seconds, a very powerful technique is to do some thread dump sampling. It's called kind of thread dump sampling. So in this case you will generate thread dump every 3 to 5 seconds, and then you'll look at the thread stack trace and see where the thread is stuck or what the thread is doing. Whether it's waiting from a database, from an external web service call, or maybe is there lock contention? There could be also a deadlock situation, even though it's rare, still possible. So that technique will essentially break down the response time in silos. And by reviewing the stack trace, you'll be able to see what the thread is doing. In this case, what we want to demonstrate is a line number change in this example, right? Since you'll see a line transitioning from 116, 117, 118. Okay, that's what I want to demonstrate. To do these techniques, we're going to use JStack and generate multiple snapshots of JStack like this. Okay, so we'll locate ourselves in the logs directory. The technique is use JStack, the process ID, and then we will create an output file, and we'll call it threaddump1, threaddump2, threaddump4, etc. every 5 seconds on a single request that we're going to do. Okay, so let's start. We're going to initiate another request. Now let's see this request live. We see thread 36 is sleeping right now, so we're going to generate our first snapshot, threaddump1, right? As you will see, it created a single file with threaddump1. Now we're going to do the same thing after 5 seconds, threaddump2. And the technique is very useful because you can, as I said, depending of the response time, especially if you're getting like 10, 15, 20 seconds of delays, you can generate multiple snapshots about 3-5 seconds in between, and then you will analyze the transition of the thread execution pattern, right, in between the snapshot, and eventually you will know exactly, where the problem is. So in this case, we have quite a few snapshots already. The thread is still spinning, as you can see, so we'll probably get a last snapshot and then we'll start to do the analysis. So the request is completed. As you can see, it's our thread 36, which is the same thread 36 as we saw. Now let's look at the first thread dump 1. As you will see, if we search for slow, which is our JSP name, the actual thread is sleeping at line 116. This is from our first snapshot. Now let's see snapshot 3. The thread is sleeping at line 117. So this is actually the same thread, the same request, right? But of course, since we simulated kind of a slowness, that's why we said transition, right? Because the first sleep call did complete. Then this is our second sleep call. And eventually we'll see our last one, line 118. Which is our third sleep call to the thread. So that's what I wanted to demonstrate, because that technique is very powerful, right? Because depending what the thread is doing, you're able to compare between the thread snapshots like we did with JStack where the thread is doing. So you will be able to do it, as I call it, a transaction or response time breakdown analysis. So you'll basically break down the slowness in buckets, and then you may determine that, yeah, I had one database call that took 2 seconds. Oh, I had this web service call that took 15 seconds, and maybe in memory processing took less than 1 second, right? So with this analysis, you will be able to identify the top two or top three contributors of your performance slowness. Now, this is not going to replace a full profiling activity, but in production it's very powerful, especially if you don't use advanced CPM technologies, tools like Dynatrace or AppDynamics or even New Relic. This technique is very powerful to break down response time and show you potential problem. I hope that you enjoyed this video. Now this will complete the thread dump generation techniques as we saw, and then of course the next video on the thread dump will be focusing on the thread dump analysis patterns, which I will show you multiple type of problems that we will simulate in our lab, and then I'll show you how to analyze that, and we're going to use that across multiple containers, Oracle WebLogic, Apache Tomcat, and also IBM WebSphere. Okay, so thanks for watching.